This is number 55. The directions start on page 287 for lesson 5.4. Says, in exercises 54 and 55, f is a differentiable function whose graph is shown in the figure. The position at time t in seconds, so time is going to be in seconds, of a particle moving along a coordinate axis is s equals the integral from 0 to t of f of x dx, meters. So the position is going to be in meters. The time is going to be in seconds. Use the graph to answer the questions. Give reasons for your answers. All right, turn to page 288. This is a copy of it on the projector here. This All right, so t is time in seconds. S is position of this particle. It's moving along like an x-axis, for example. Okay, that's what we're talking about. It says moving along a coordinate axis, so we're going to say it's along the x-axis. So whatever I come up with s, that'll give me its position. So if like s comes out to 1, that means it's 1 meter to the right of 0, 0. If s came out to like -2, that would mean it's 2 meters to the left of 0, 0 on the x-axis. So this particle is moving along the x-axis. All right, what is the particle's velocity at time t equals 3? Well, if s is position, do you guys remember what do you do with the position equation to get velocity? The derivative, yeah? So let's just do that. The velocity, the derivative of s will give us velocity. If we do the derivative of our integral, what's going to happen to the integral symbol? It's going to cancel out, yep. It's going to undo that. So doing the derivative of s and doing the derivative of the integral. Derivative of s is v, the derivative of the integral cancels. What do I do with the t? Put it in for x, so you can have f of t, and then times by the derivative of t, which would just be 1. Okay? So our velocity is actually our f function here. What is the particle's velocity at time t equal 3? So in other words, to get the velocity after 3 seconds, we're going to put 3 in for t. So we're going to find f of 3. So if I go to my graph, there's 3 on my f of x graph. What does f of 3 equal? 0. Yeah, I'm just looking at the y-coordinate. The y-coordinate equals your f of x. So it's going to be so 0, let's see, if the position is in meters and the time is in seconds, what would the velocity be in? Meters per second, right. So at 3 seconds, the particle's moving 0 meters per second. Which means it's either standing still or kind of switching directions at that point. All right, A is done. Part B. Is the acceleration of the particle at time t equal 3 positive or negative? Well, we know that this is this graph is a velocity graph. We just figured that out. Velocity equals f of t. So this graph is velocity. So how could I see acceleration if I'm looking at a velocity graph? The derivative, right, yep. The derivative of velocity is acceleration. So I'm going to have f prime of t. Now how can you look at an f graph and see whether f prime is positive or negative? Slope, yep, good. So that's going to be the slope of f of t. So keeping all this straight and writing it down is key. So the acceleration is going to be found by looking at the slope of f of t. So at t equal 3, is the slope of the velocity graph positive or negative? Positive, right? We're going uphill right here, increasing function. So that means the acceleration would be positive. The acceleration is positive because the slope of the velocity equation is positive. That's B. Any questions about that? Part C. What is the particle's position at time t equals 3? Or which letter up here represents position? S, right? So let's find the value of s after 3 seconds. So all you do is put a 3 in for t. So we're going to do the integral from 0 to 3 of f of x dx. So how would you find an integral by looking at this graph? Between 0 and 3 seconds. So from here to here, I need to know The position. The position is given by this integral. How do you find the value of an integral with a graph? We did this in lesson 5.2 a whole bunch. A little bit in 5.3. Yeah, it's this area. This area right here will give you the integral. Remember, an integral can be found by finding the area. This area right here. So let's find that area. So how wide is the base of it on top here? 3. How tall is it? 6. So base times height divided by 2 gives the area of a triangle. Can you get that set up right again or not?
Maybe.
I'll get it.
It's okay.
Paul doesn't feel bad anymore. He's not the only one that's done it.
Yeah, I was thinking that.
I really been, I just moved my leg. I don't even think I touched it though.
Huh.
What do you do there?
That's not a real sturdy stand. It's convenient, but not sturdy. Okay. So anyway, the area of this triangle is going to be 3 times 6 divided by 2, so that's 18 divided by 2, that's 9. But notice it's below the x-axis, so what would be the integral? Negative 9. Yeah, the area is 9, but the integral would be negative 9, because it's 3 times negative 6 divided by 2. So find the particle's position at time t equal 3. So the position is negative 9. What would be the label on that? Meters. Yep. That meaning it's 9 meters left of the origin. Any questions about that? So notice that the integral gives you the position. The y-coordinate of the graph gives you the velocity, and the slope of the graph will give you the acceleration. So we can find all 3 things off of this one graph. When does the particle pass through the origin? Well, it's only going to pass through the origin when the position is 0. Position of 0 means it's at the origin. So I'm trying to figure out when the position, when this integral, when that position integral is going to come out to 0. Any ideas when that integral would be 0? Well, and hold on here, this should not be a 3, this should be a t right here. So what value of t would make this come out to 0? 0 would, yeah. If you're trying to find the integral between 0 and 0, there's no area between 0 and 0, so t equals 0 would be 1 time. Now, we know after 3 seconds, let me draw a picture here for you. So here's our particle, moving back and forth. After 3 seconds, we know it's out here at negative 9. Okay? Is it ever going to get back to 0 right here? That's what they're asking.
6.
Why 6? You're right.
Because 3 is the same triangle.
Right. This triangle is the same triangle, right? So this triangle down here means the particle's moved 9 meters left. This triangle up here have an area of positive 9, because it's 3 wide, 6 high. So then it moves 9 meters back to the right. So if it moved 9 meters to the left during the first 3 seconds, and then 9 meters to the right during the next 3 seconds, it's going to be back at 0 again. The integral from 0 to 6, can you see that this area that's underneath the x-axis would cancel out this area up here? So the particle would be back where it started, which is at the origin. So the second time that it'll pass through the origin would be t equal 6 seconds. So 0 seconds and 6 seconds. And then the fact that this other area, that the remaining of the graph has positive area, means the particle's just going to keep moving to the right. It's going to keep going this way then. Okay, so it won't hit the origin again. It's going to move left 9 meters during this negative integral, and it's going to move to the right this whole time here, because it's above, the area is above the x-axis. Okay, part E, approximately when is the acceleration 0? Remember, acceleration is the slope of our graph. About 7 seconds. Yeah, it looks like the slope's 0 about right at 7 seconds. So t equals 7 seconds for part E. You're just looking at the slope of the velocity graph to get your acceleration. Part F. When is the particle moving toward the origin? When's it moving away from the origin? So I'm going to put this down here where we have a little more room. Toward the origin and away from the origin. Well, during the first 3 seconds, we said that it initially started at 0 right here. During the first 3 seconds, it moved to -9, right? Because this area is 9 below the x-axis. So would it have been moving away or toward the origin when it moved from 0 to -9? Away. So one of the intervals when it's moving away from the origin would be from 0 to 3 seconds. Well, actually, 0 to 3 seconds.
Be curved, right?
It'd be curved. At 3 seconds, it's actually switching directions. So I wouldn't really say that's moving toward or away, the origin. Okay? Moving toward the origin. Well, after 3 seconds, it turns around. That's what's ahead of velocity of 0 up here. It's switching directions and starts moving back this direction. And for how long is it moving toward the origin again?
6.
Through 6 seconds. Yep, between 3 and 6 seconds, it's moving back toward the origin. Then at 6 seconds, it goes through the origin and starts moving and keeps moving to the right. So as it moves to the right, between 6 and 9 seconds, a little over 9 seconds, would it be moving away or toward the origin? Away. Yep, it's moving to the right, and it's already gone past the origin. So again, from 6 to, I know it doesn't quite show 9, but I'm going to just estimate it at 9. From 6 to 9 seconds, it'd be moving away from the origin again. Kind of tricky. Any questions about that?
Would they be closed brackets not curved?
Well, at 6 seconds, it's just passing through the origin then. So right when it's at the origin, I guess I'm saying it's not really moving away or toward. I don't know what the back of the book will show. Maybe they'll say when it hits the origin, it's doing both. It's moving toward the origin and away from the origin. I'm not sure. And at 9 seconds, I guess it still has positive area, so that, it really probably is actually a little bigger than 9. Maybe like, I could estimate that at 9.1. So I could put 9.1 with a curved bracket. When it hits 9.1, it's going to have a velocity of 0. So then it would not be considered moving toward or away, I don't think. I wouldn't get too caught up on that on this problem. G, on which side of the origin does the particle lie at time t equal 9? Where does it end up at? Right or left side of the origin? Right. Yep. And did you say left? Should be right. Yep. Particle's going to end up over here. Okay? Because this area below the x-axis means the particle moves to the left 9 meters. This area above means the particle's going to move to the right. This area will tell you how far to the right. Because this area above the x-axis is greater than the area below the x-axis, it moved further right than it did left. So that means it's got to end up over here on the right side. Any questions about that? Okay, let's stop that.